purpose. And thanks for the students also are contributing to the sessions. That's really good. This session we will try to convert into the bidirectional instead of just monotonous. I keep on speaking, but maybe because of our limitations of not having face-to-face, maybe at the end we will reserve some time for the questions and answers. Maybe when I'm showing the presentation, you can remember the slide at which you are asking. If the question is very important at that slide itself, you can interrupt. But otherwise, I think you can tell me to go back afterwards in the question and answer sessions, and we can go backwards and forward in the presentation. So let me start with the presentation and sharing the screen. Okay, are you able to see my screen? Maybe someone can answer.
Yes.
Okay, am I audible clearly? Is my voice very clear?
Yes, sir.
Yes, sir.
Okay, yeah. Okay, so let me continue. Today we are going to talk about a limited or restricted topic in the software architecture, and a very small means by volume topic called as the quality attributes in the overall software development. Now inside a software development, you know that there are lots of things like design, maybe implementation, architecture, and so many other things. Within that, architecture is an important step. Architecture, the word itself is a bit confusing still in the industry. It's not the question about the academics or industry. In the industry also, software architecture, still people are trying to understand what architecture is, what is the difference between the software architecture, software design, software implementation, system analysis, and all those things. This term architecture, in general, I believe it must have been borrowed from the civil engineering. If you see the difference between the architecture and design in civil engineering, it becomes easier for us to understand the background or context in which we are speaking about the quality attributes. The word architecture in civil engineering, which suggests that the architect is not really a mason. Architect may not be a very good mason, may not be a very good carpenter, may not be a very good welder or making the window frames and everything. Even architect may not be an excellent RCC designer, or for that matter, maybe the other things which are required for the constructing the building or structures. But architect basically is the front end interaction with the customers first. Architect will try to understand exact requirements of the customer, because suppose customer says that the customer means the person for whom the house is being built. The person says that, okay, I want a house and I want a one room for my online trainings. Now this requirement is completely different from an old couple who wants to stay there peacefully, and the old couple says we want a very big prayer room because we are very much interested in praying and meditation, and we want a room which will be required for that purpose. Someone will say I want a gym and everything, and you will observe the civil architect will convert these ideas into a framework. Now this will not be a very tightly bound framework, but he will generally chalk out the rooms and the areas, the staircases. Necessarily the architect will look at the convenience of the users, and he will try to convert those requirements exactly, or the needs, into a sketch and of course the description, where the end user is kept in mind. Now the drawing goes and gets it into the hands of the RCC designer. RCC designer is going to say, okay, you require a gym on the second floor, right? Then I need to increase the column structures. I need to have a very heavy beam structure maybe. Now, if this is the thing, the RCC designer will construct his framework, his or her, of course, this is a women's college, so we shouldn't be biased towards the word called as his. So the civil engineer the RCC designer will design the concrete columns and the dimensions, and again she will hand it over to the architect. No, architect will say, no, this column is coming in between my parking or my say the gym, and I don't want it here. So you will observe the design and architecture, they go hand in hand. Then of course the other people, they are going to contribute to the complete building. Similarly, for software architecture, a general term is software architect is going to convert the user's concrete requirements by keeping in mind what kind of user it is, because user might have different requirements. If it's an old person, the person who doesn't know computer programming at all, typically the people who are like 80s and maybe above 70s and 80s, and they do not know too much about logins, user IDs and passwords. I know an old lady who was telling me that I wanted to log into a Facebook, very old lady in US. She was telling, I want to log into Facebook, I want to use it, I want to learn it, but Facebook is asking my password. Of course, at login. She says, why I need to give my password to Facebook? They will misuse it. So here itself comes into the picture, the requirements, what end user is looking at. And if end user is looking at your screen in a wrong direction, then of course the software will not be used. So how do you design the, how do we put forward the concept into architecture? Now, to answer this question, of course, people need really try initially to find out, is it an art or a science? That can you teach painting to someone? I believe not. We can teach someone to copy exactly like the way Apple looks like. It's like a still life. You can draw a still life. Maybe you can teach a person also, but you cannot teach a person to make a creative drawing, because that creativity part is the portion of art. This is what is my personal definition. It need not be very hard and fast about the philosophical thinkings. But I believe that if something can be taught, it is not an art, it is a science. If something cannot be taught and person is actually creative by maybe birth, by maybe the environment, or maybe for any other genetic reasons, and everyone cannot become the vocalist of the world famous level, because the art of vocals or the instruments, that comes under the part of the art. A science is of course why the violin makes exactly same sound and what is the timbre and everything. Similarly, into software architecture, when we think, if we answer this question, that maybe now this is not this forum won't allow us to take the opinion poll because we want to save the time. But I have asked this question in many of the classes, and some people feel it is science, some people feel it is art. Maybe you can have your answer with you. Just keep it with you at this moment, and then let us discuss. If we answer that this is a science, then we must have a very, very clear rules to define it. Because if I hit the billiards ball, it is going to hit another ball, and the Newton's law of forces will come into picture, and the momentum will be preserved and everything, and that's a science. And you can of course predict where the ball will go, and you will get the points. But if we answer that if it is a science, then if 10 people apply to it, all should get the same answer. Because for the physics paper, if you ask a question, there will be a correct answer to it. Most of the times, not always, but most of the times there will be correct answer. But if it is an art, it might happen that there are 10 answers to it. All 10 might be right, because it's a portion where the architect can really creatively think of a different solution than the one which was existing. But the problem is that if it is an art, then it's an individual expression, and we cannot really multiply it. And for the business, you really can't depend on the art. If someone says that, yes, it's an art and I can be architect, but you cannot be. Such an architecture from an architect like this, like Leonardo, that's possible. People have been like Buckminster Fuller or people like this. But it will be really an expensive task to run the projects with such kind of architects, because you will never get them. Even if you get them, they will be so much expensive that the projects will not go ahead and no one will buy those, because the cost has really increased one. So always the people who do research in the field, they try to convert the maximum portion of into science. See our education system, the engineering itself. There are parts of engineering which can be taught in the class, in the academics. But when person actually goes on with the machine or the software, the problem which person is going to face, maybe she is going to face it for first time, and no one really has faced it. And that problem has to be solved with the artistic mind and the creative thinking. So it is, let us treat this as a combination of science and art. The portion of science which we can learn, portion of art which we can develop based on our experience and maybe learning from each other. If we want to convert it into science, people have tried to elaborate on the given, say, terms. They define certain terms, you need definitions, you need the specifications to be written. And you will observe people have arrived at some of the terms in the software field. Now we will see software is the most broader field into it. Our software architecture fits into that framework somewhere. Within software architecture, the quality attributes are going to fit. So let us start from the bigger picture, arrive at and converge with our smaller part, and then try to understand the today's context. This is for setting up the today's context. SDLC, everyone knows software development life cycle, and there have been many animations, many jokes and everything. And especially in the current stay-at-home scenario, there have been not many other jokes also on SDLC. So I want to elaborate on that. The requirements, we understand that requirements are the expressions of actually maybe end user or the stakeholders. Need not be always the end user. The stakeholder can be actually the system maintenance person. The system financer also can set the requirements that cost should not go about this and everything. What do we mean by analysis is also must have been covered in your sessions for sure, because we start our software with that. And analysis is the one, typically there are business analysts. The role is called as business analyst, need not be always a separate person. A same person might be using a hat of a business analyst when person is going to do the analysis part of it. So we accept the requirements, the experts do the analysis of it, they make or elaborate the requirements. Now the requirements come into a concrete form where we can address the requirements with the appropriate bullets. At this stage, once we understand the requirements, this is what exactly the civil architect will do. Civil architect will maybe have the meetings with the customers or the person who is going to have the house or who is going to be the owner of the house. And the architect, she will ask many questions to the customer. What kind of the house you like? Do you like the modern frame or the completely the new architecture kind of a thing? Or you really want to have a mud house or the old type of the old-fashioned house? And so many things, and the requirements get converted into the something called as an architecture. Through, of course, it goes through analysis. Now architecture becomes the main framework. Still it is not very concrete. The architecture will tell that what kind of rooms will be there, the room sizes will be there, the rooms on which rooms will be on first floor, ground floor and everything. Then it gives into a stage called as a design. Design is something which, of course, you must have learned about the UML, the class diagrams and everything. We arrive at a concrete design. We arrive at something called as a class model, state model and other things. And that is part of the design. Again, the design, again, some part is a science, some part is a art. Once the design is ready, people go for implementation. Now, this cycle sometimes comes under the waterfall model, that you go only once into one stage and go ahead like a waterfall and do not come back, or it might be agile. You go into the small iterations, you again come back to the next set of requirements, again analyze, Of course, architectures, people won't do it in the pieces, but you can revisit the architecture, like the example of civil engineering, that if the column is coming in between somewhere and in the hall, and the architect says, no, I don't want to have the column here, then the civil engineer needs to consider some different solution to it, such that the column cannot come in between. So the solution goes through iterations, analysis and design, and people arrive at something called as the implementation. Now this implementation is the one which is going to actually run on the servers, or the end users are going to see things because of this implementation. Now to define all these things, and if we observe our aim, one aim is that to convert this into science. If it can be converted into science, it can be taught to thousands of people, because it becomes the part of the process, even though not a ritual, but the part of the process. And people are not going to follow it blindly. And we are engineers, so we are not supposed to follow anything blindly, but cautiously we have to follow it. So if we are going to convert this into science, we need something called as a system definition, means how my system should be. If I am able to exactly express what exactly I want, the solution is going to tell us whether it is going to fulfill the end requirements or not. The solution which is provided and which does not fulfill anyone's requirements, or partially it does not fulfill the requirements of some of the stakeholders. For example, the software has been giving an excellent performance, but it has exceeded the cost limits by the financiers. Or if it is within the budget, but software is failing repeatedly. Such softwares are not a success in the field. Even though people are free to go in that way, but that's not a successful way of achieving the good results. Now, there needs to be some way to define how exactly I want my system, because requirements can be very, very vague, and requirements can be elaborated in different fashions. Now, if at all, I'll give you a very flexible or the fictitious example, that every child in a childhood, the mother says, no, you are not a good boy or a good girl. Okay, then the child, if child is very interesting and find out what is exactly going wrong, child will ask the mommy that, okay, what do I need to do exactly to become a good boy? Now the question becomes very difficult, because if the mommy says that, yes, if you go into market and buy something when I require it today, okay, now you go into market and buy XYZ thing for me. Now child says, yes, I'll go and I'll get it. Now am I a good boy or something? Now there are certain definitions by which we can say functionally, yes, the kid has gone into market, purchased thing from the nearby shop and came home. Requirement was fulfilled. But a stamp given that a good boy, next day can be really spoiled, because next day the child will say, I won't go. I have got my studies, or I want to go for playing. Now there is a second part of the definition of what is good and what is not good. There are two parts of it. One is called, we call it functionality, meaning that because if you concretely define, the kid is very clever. Kid is trying to capture the mother's words into a very scientific way, so that the kid can prove that, yes, I'm a good boy or a good girl, and you have to agree it. In that fashion, if the mother falls into this trap, and mother says, okay, these are the 10 things, if you do it, then you are a good boy or a good girl, respectively. And the child says, yes, I will do all these 10 things, and gets a stamp, and from next day onwards, again the next stamp comes that you are not a good boy or a good girl. So functionality can be defined like the way that we define the ability of the system to fulfill the work intended. So exactly what we are doing, if it is a banking system, it will allow people to withdraw money. It will allow people to say deposit money, see the balance and everything. A very, very trivial example which everyone must have given it. How do we define these things? Described by functional requirements. Now we are going to see the difference between the functional requirement and a non-functional requirement in a short time. How do we capture these in a scientific way? We make something called as a use case analysis. And I am sure being the software in the software field, you must have heard this word use case analysis. In fact, you must have done the exercise also. UML models, and believe me, there is a lot to learn between these two things. These two are the object-oriented analysis and design, and it might create you food for another 5 to 10 years just for learning it. So use case analysis or UML models capture the functional requirements necessary that they will always be fulfilled if they are fulfilled once. They are repeatable in nature. That if you can withdraw money, yes, there is a clear-cut result, yes or no. You click this button, the A button, B button, C button, select the option and click E-submit button, you will be able to transfer the money. This is like a test case. You have written the test case and exactly the expected results matches. This happens with something called as a functionality or functional requirements. And that is why we can capture them into use case analysis, UML models. Those are repeatable in nature. How do we achieve those things into our implementation? We will have components, we will have modules, we will have subsystems, and they work in coordination together to achieve a bigger results. This is what our the definition of object-oriented decomposition, that there are many objects or components, they come together and they collaborate with each other to achieve the functionality which might be larger than their individuality functionality sum. So if 10 people are going to do each one unit of a task, 10 people coming together will deliver 12 units of the tasks, meaning they exceed their individual sums. So this is the way we talk about something called as a functional requirements. But the example in our example of the kid and the mother, the kid says, yes, I have fulfilled the functional requirements. Now I am a good boy. Problem is that mother says, no, this is not enough. You need to be consistent for next week. Now this is where somewhere the other part of the conditions they apply. It's like a small with a star. Mother has given the invisible star that conditions apply. Conditions apply that you must behave in a consistent way for next week or next 1 month, then I will give you that whatever gift or anything is there. Because behaving in a one day or fulfilling only one requirement does not satisfy the end user. Similarly, in the software also, we have got other part that system exactly works today and tomorrow it stops working. In such a case, you can't say system was correct. System worked on the test case day or the exam day. The student gave excellent answers in an interview. Problem is that next day onwards, when the actual work came into company, the student was not able to, as an employee, student was not able to do the work. So they keep the period of say 1 month or 3 months that you have to show a good performance and then you will be made permanent. Something similar to this, the requirements or the expectations which cannot be captured into functionality are very concrete statements that system, if you give A as an input, you should give B as an output. Wherever you cannot exactly say this, the second part or the component of requirements is captured by something called as by defining the quality attributes. Now, quality attributes, we'll see shortly what are those, but those need to be considered almost throughout SDLC. Whereas the functional requirements, you will see that in the SDLC, at requirement stage, the use case analysis might come into picture. Maybe at the system design or the domain design, you will do the class modeling, the state modeling, and other things. But that's not the case with the quality attributes. We need to consider them from requirements till the end implementation. These are more broader aspects of the system, that it's not about today only going into market and buying something for the home, but consistently for a month, you should show a good behavior. A bit vague statement, But now child wants to say that, okay, what do you mean by I need to behave in a good way for 1 month continuously? Can you elaborate? Yes, whenever I tell you to go into market and buy something, you should do that. You should help me in cleaning the house. You should help me in XYZ and other things. These kind of requirements talk about the longer or the broader aspect of the system. So system should function continuously for so many days. System should not fail. System should not. The system should be useful for the end user. Because if the system's target audience is a very old people, I will give you the example of that later on. The example itself, there was the requirement on which earlier, a long back I worked. This was the insurance for the funeral. Yes, I mean, initially we might laugh it as a joke or something. People had made a jokes on it, but it's in reality, there is an insurance for the funerals. Typically, people in US and Canada, I think it's a very difficult task for old people to think of their funeral and whether someone will pay for that. It's a bit expensive. That is what I heard. I don't have experience, but it's heard. So people have come out with, a company had come out with an insurance that you pay amount, a premium for something, and the company will take care of your funeral. Now, we were working on this requirement and our client said, see, our target audience is very old people, especially in the old age after 60s. People start thinking about, they start getting worried about their funerals. Now, people beyond 60 at those years, maybe 20 years back, they will not be knowing computer systems very well. They will not be able to understand your vocabulary of submit buttons and everything. They probably will have a very weaker vision. They might go half the way in giving the information and suddenly quit in between, and again they will try to log in. So you must have all these aspects considered in your system. So in the end, the font size should be sufficient such that person can see it. It should not be very fancy. It should not be very with the gaudy colors or anything. People might leave the website suddenly in between and again reappear. And these are the things which these things keep into mind about the target audience. Now, overall usefulness can be like this. If people do not use it, then such a product is going to be a waste. It's going to be a waste of investment. Now, these quality attributes are going to be the basis for designing or defining a non-functional requirements. Now, these are what is called as non-functional requirements, which cannot be captured in something called as a use case, or you give A as an input and you expect B as an output. It's not like a test signal that you give a step input for the control system and you expect the output, which is the delayed response. And such things are non-functional requirements. Now, these are the concrete things which typically people will ask. The architects will try to find out answers about these. There can be in the civil engineering example, house can be built by I want gym and everything. I want the windows and everything. An architect in a very funny animation cartoon, I saw one. The last example, the architect says that, okay, then I'll finalize your requirements. The lady owner says, okay, but I think I forgot you to tell that a very minor things, that I do have 3 kids and they are very naughty. They have already broken 10 times the glasses of our house. Now, this is not something which is a functional requirement. This is non-functional. But yes, architect needs to consider that there are kids. So there cannot be very sharp corners. There cannot be glass doors at every place. Similarly, the non-functional requirements, we are making a basis for defining or maybe capturing exactly, helping the customer expressing their non-functional requirements. Now, these non-functional requirements involve 2 types of things or aspects. One is architectural, one is a non-architectural. So I know it's going typically like the zoological, the classification. the phylum this, within phylum, then phylum core data and into it and everything. We are saying software, then architecture and design, within architecture, the quality attributes, architectural aspect and non-architectural aspect. But this is going to help us in capturing very accurately, or at least not pinpointing, but at least making it more narrower. Making it more narrower helps in understanding in the context. Okay, I'll keep a view at the watch. Yeah. So certain things are, these do not read as completely a non-architectural concept. There are some architectural, some non-architectural. And I'm sure you must have gone through the software architecture as such. Architecture is going to talk about which components will come into system, which might be the components which might be purchased afterwards, which might be developed indigenously into the company in-house. The component communication between them, how they are going to communicate with each other. Is it going to be the HTTP protocol? Is it going to be the, what is that with the machines? I think UPI, OCU or something. OPC-UI, which kind of the communication pattern we are going to use? Are we going to use queues, or it is going to be the asynchronous communication? These all things are, and they are coming under the architectural aspects. The shared resources are nothing but maybe the databases, maybe the queues, maybe repositories. And we need to give consideration to shared resources, and shared resources are going to decide how the system, whether it is going to fulfill the non-functional requirements or not. Because if there is a shared resource which is being accessed by thousands of components of our system, it's going to get blocked. Because when one component is going to use it, another component is blocked from using it. For example, database. If database starts getting very frequently locks for reading and writing, the overall performance might be impacted. Now, soon you will listen that performance is also one of the non-functional requirements criteria. There is other aspect of it which also can impact on the thing called as the quality attributes. We haven't yet, I know we haven't yet seen what are the quality attributes and the enumeration of that, but we'll come to that soon. One is the coding standards. Now, coding standards, you will listen into the industry. Once you enter into industry, you will find out that you will have the coding standards or the specifications. Even though Java is going to allow the individual variables to be made, the instance variables to be made private, protected, public, or the default. But as a rule, maybe I will tell you as a team leader, always make it private, because it is the coding standard. And you will learn later on that always this can be a very good standard, that make always it as a private. And if you make it public, the compiler is going to allow you. The system is going to function, but system is going to be very fragile. And coding standards, if they are not there, your system can start failing. So coding standards are going to definitely impact on the overall system in a non-functional environments. There can be a choice of algorithms. The choice of algorithms are such that they are error prone, and they are error prone in the very specific conditions, that when so many people access to it and multi-threading fails and the algorithm fails. So in summary, the attributes can get impacted by two different things. One is the architectural part of it, or aspect, division of functionality, communication patterns, what we have identified in the architecture. All these things are going to come into the architectural document, but these may not come into architectural document because they might be the company, across the company standards, or those might be applied by the customer themselves. So we will have to understand that there are two aspects of it which might impact on a given specific quality attribute. For example, the maintainability. The word itself suggests that my system is maintainable, means it is very easy to repair. If at all something goes wrong, right now the mobiles, right? We observe that mobiles in earlier days, before few years, I do not know whether you have experienced those mobiles, we could change a battery. We could change a battery for a mobile on ourselves, and we could just buy a battery and change it. Now all the mobiles, we have to take them to the service station. Most of them, we have to take them to service station. So in a maintainability wise, they are not that easily maintainable by us. Or sometimes of very small systems, we can at a home itself, like a bicycle. I use a road bike. For a road bike, getting a puncture on the big ride like 100 kilometers or more, it's very frustrating. You can't find a puncture shop. So what you need to do is, we have got something called as a quick release mechanism. Means you just turn the lever and you open the wheel nut. Within moments, within 30 seconds, you can open the wheel, you can take out a wheel, you can take out the tire tube, you just replace the tube with the new one, fit it immediately, and start again riding back in 10 more minutes. System is maintainable, whereas the other bicycles, they are not this way maintainable, because you may have to take them to a shop. Now, why people are not making all bicycles maintainable in this way? Because nothing comes free. Nothing comes free, so quality attributes or the architectural aspects will always have the trade-offs. If you ask the customer will say, yes, I want system tomorrow, I want system 100% on, I want system to use 1 million users simultaneously. The architect says, yes, I will give you, but it will require so many $1 trillion, and I will give you. No, then reduce it. Then system should be available maybe 99% of the time. A simultaneous user, I'll bring them down to 240. Believe me, there are lots of trade-offs, and the mastering the trade-offs is really an art of architecture. So this kind of maintainability or any one aspect, we cannot stretch it to a limit, because the other one starts going down. Because for the road bike, the costs go above, the cheapest one might be around 1 lakh, and the costliest might go anywhere else. But whereas the daily maintenance bikes, they are available from 2,000 to 3,000 rupees. Exactly same thing happens in the software field as well. Now here we come to the list of our quality attributes. Now these are some of the quality attributes. This is not an exhaustive list. There are many other. If you just go to Wikipedia, you will see a big list. But we have chosen most important ones, because there are few other things which we may not come across directly. Some of them, like observable, making the system observable, controllable, and other things. Typically, these words end in some ability. So people might say it as under different names, X-ability or something people say it. X-ability kind of a thing. And these are the things which we are going to consider in short, enough for your as the starting package. Afterwards, you are going to further drill them down on your own for coming few years. Believe me, it might be sufficient for you for years to drill them down. One by one, we can see those. But before that, let us see with our context of making them more scientific. See, we don't want to believe in the intuition or creativity. We do not have a magic, say, lamp in front of us that we ask the lamp that what I need to do, and the lamp will tell me. We don't have any magic stick like this. We must believe on our systematic efforts, and to make them systematic, a quality attributes, experts have defined certain things by which we can document them. For example, in the design patterns. To document a design pattern, you know that you write down the rules, you write down the typical scenario, and you write down the collaboration, you write down the intent of a design pattern. The idea is that even if you come out with a new design, it's like a framework. If you come out with there are 23 design patterns you must have learned. No one is stopping you from identifying the 24th design pattern. You can always find 24th one if you can define in the context which is given that its intent, the rules, responsibilities, the collaboration. Yes, you have got the 24th one. So to define a quality attribute or to understand a quality attribute, there is something called as a scenario. Now, scenario means it's a broader term used for making understanding about a quality attribute. Now, what is attribute and what is actual value? When we write a simplest class, we say class has got attributes. Like the Cartesian point as a class has got attribute called as a x value and a y value or coordinate. Now, x and y coordinate, so it says if you want to have a specific instance of class called as a Cartesian coordinate, then you must have a value for x, value for y. So it is giving you a rule that if you want to make a specific point in the xy coordinate system, you give a value to x, you give a value to y. It might be 0, it might be -1, 2, or anything, but it needs to have it needs to fit into this framework of creation. Similarly, the attribute is going to define that the framework by which you will be able to, the customer will be able to see, yes, that I want to talk about, customer says, I want to talk about availability, and the word itself suggests that availability means system should be available. Now, exactly, let us go into our counterpart. Architect asks, how much electricity backup you want in your building? Person says, yes, 100%. Architect says, no problem. He consults the electrical designer, electrical consultant. Yes, in this building, the load is suppose 130 kW, for example, complete building. And to have the 100% availability of the power, we need to have the 3 generating sets, 3 electrical generators. We need to have a battery backup. We need to have a changeover system, and this will cost another 20 or 50 lakhs, for example. Now, customer has to either agree to this cost or customer will have to reduce the requirement. No, it's okay even if after it takes about 1 minute to start to change over to the generator set. So again, the factor of the compromise or the trade-off comes into picture. But necessarily, we have given the opportunity to customer to define in a very concrete way what kind of availability you are talking about the power. What kind of modifiability are you thinking that your structure can be changed in coming few years? Then building owner says, yes, I'm going to give it on rent to different banks or the software firms. Architect will, yes, will take the corrective action. Instead of having the concrete walls in between, let me put the soft partitions. Because the system will be modifiable, my building will be very easily modifiable into bank or anything. Now, there are studios for shooting. Those can be easily converted into one day from the palace of the Mughal Sultanate to suddenly a temple of Tirupati. They completely change the setup because everything is so soft and modifiable. So these kind of quality attributes are going to help us in capturing the requirements in a very scientific fashion. And once we capture them in a scientific fashion, it's very easy for us to address them in our solution. One is address them in a solution. Second advantage is if those become to some extent testable. That have I provided this or not? Have I provided modifiability or not? The answer is very vague. So, for example, typically you will observe in your B project reports, most of the students as a functional or non-functional requirements write a first requirement, software should be user-friendly. What is meant by user-friendly? It doesn't mean anything because it doesn't capture anything concretely. Because the developer says, yes, my software is very user-friendly. The customer says it's a hopeless software, but I don't understand anything how to use it. And now the fight starts. Now, whether the customer should pay or not, because there is no judgment whether it has been fulfilled or not. So system needs to be user-friendly is not at all even a functional requirement. It is not even a non-functional requirement. It's a very, very vague statement. It's absolutely not at all a scientific statement. But if we try to capture them, and this is where actually the quality attributes help us. So what do we say? A source of stimulus. This is, I know this is a little bit more in a very cryptic way, but we'll try to understand it. So source of stimulus means who generated it. There must be some reason by which this situation has been generated. A scenario means it is a situation. It's like if this happens, what will happen? This kind of a thing we are talking about. So we are saying that the situation or scenario must have appeared because of someone's trigger. It might be someone or something. It might be a human being, or it might be a software component, or it might be a hardware component. Because the alarm starts buzzing suddenly, the fire alarm, because someone in the kitchen had given a tadka kind of thing. Now it was not a fire, but it triggered out. Now stimulus is the condition of importance. In this case, what is the condition of importance? That a fire alarm has been generated. In which environment there has been some smoke around and the stimulus was given to the system. The source triggered the simulation, the stimulus, sorry. Now, which is the artifact? What has gone under the threat or the consideration? Is it a whole part or whole system or a part? Artifact means whatever our software, it might be code, it might be design, it might be test suite, it might be test case or anything. Response is how the system is going to respond to the stimulus. In the building case, if at our fire alarm comes, the sprinklers are going to start the responding of this stimulus. Now there must be some measure of that, because if there is no measure at all, how will you say whether I have fulfilled the condition or not? The condition can be put by the customer that yes, if there is a fire hazard, within so much time, the sprinkler should start. Now this can be one of the measures, not necessarily only this measure. There can be another measures that continuously, for suppose the alarm is switched off, it's a false alarm, immediately it should not be triggered by the same reason again within 1 minute, for example. Are you getting it? I am not talking about system being user friendly in a very vague way. We are trying to capture these things into numbers, because we are saying that after the smoke generation, within so much time, say within 30 seconds, the sprinkler should start. Now within 30 seconds can become 50 seconds, can become 10 seconds, can become 5 minutes. Depending on this, that there will be a trade-off. Because if you make it too soon, it might start triggering for anything or the threshold levels. But necessarily, we are providing some measurable thing to it. Providing something as a measure, we are making it measurable. And if we make it measurable, it's a scientific or systematic approach. Now, the book has tried to cover this into a diagram. A quality attribute parts of it. The source has generated the stimulus. See, generally a scientific community is very fond of the diagrams, because diagrams convey a lot of meaning which needs to paragraphs to be elaborated. Now, the source generated stimulus for the artifact, which artifact was in some environment, which generated some response, and there is a definite measure covered for measuring it. So this we are talking about in general as a scenario to define the quality attribute. Now, quality attributes as a concrete, say availability talks about a system failure and its associated consequences. If system fails, what can be the consequences? Depending on that, people will try to define the availability for their system. So the guideline is that I want 100% coverage of electrical supply to my building because it's a hospital. In between, if in the operation theater the electricity fails, then the patient can lose life. So I need 100% coverage for the electrical supply, because if it fails, the consequences are too bad. And then, of course, the person can say, yes, availability can be this. Similarly, for software, now if we consider the software component of it, for example, the social media, if you have written the chat application and if it fails for some time, it's fine. No one is going to lose much of money. But for a bank, yes, if you start very frequently, if your software starts failing without giving a proper Windows, people will start going to other banks. But imagine the share workers, like say Morgan Stanley, because I have worked in Morgan Stanley, and imagine Morgan Stanley, or for that matter, any big banks or Bank of America or anyone in the share market time, if they lose their software, if the software goes down or any one server goes down, there can be a huge loss in the market, which can trigger an unconditional damage to the market. So in such a case, the availability becomes a very important aspect. And in such a case, typically what we would have done for the electrical generator, that we keep a backup. We always keep a backup. And surprisingly, I have been electrical engineer, and in fact, I am an electrical engineer, and I have worked in that capacity for even electrical system designs. So typically what we do there is, you keep a generator backup ready. Now, when generator backup is ready, when the electricity fails, quickly the supply changes over to the generator, but generator may take some time to start. It might be automatic or manual, but even if it is automatic, it might take some time. And you might have observed, you are in the lift of the building, the electricity fails, and the automatic announcement says that system is going to get changed over to the generator. Just wait for 5 minutes. But in case of operation theater or something, this cannot be tolerated or in the market. In such a situation, the generator is always on. It may not be running at a full load. But whenever electricity fails, within moments, the startup time is not required. Immediately it switches over to the generator. Now, in such a case, you will observe, like our equivalent in software, you have started two servers simultaneously. One is a backup server. Backup server is always ready. A main server is serving the clients. And in unfortunate situation where main server falls down, the second server immediately picks it up. So this kind of availability can be handled by creating the simultaneously up the another parallel components. Now, what can be the communication within them each other? The continuously a main server might be keeping on listening to something called as the heartbeats. That each second server alive? Is it alive? Is it alive? If it goes dead, you switch over the third server, kind of thing. So levels will go actually to the infinite level. And for say Facebook and the huge applications like Amazon, we just can't imagine wherever those people might have spread their servers across the world. Now we are talking in availability about the consistent service as per the specification. Now when the word specification comes, it's very concrete. It's not a vague thing that most of the times your system should be available. It's a very vague, because it's most of the times has got no meaning in the scientific world. In a month, a maximum downtime can be 2 hours. This is a very fictitious example, but when the bank says that server is going to go down for maintenance purpose 1 hour, it's a predicted the server downtime. Or MSCB nowadays, I think surprisingly, they send us SMS that your supply will be down for 2 hours on Thursday XYZ date. If the consistency is defined in the specification, we can measure whether your system is fulfilling availability or not. But for that matter, we need to define for my specific system a specification such that system should be available these many times, maybe say percentage times. 98% of the time system should be available. Or the failure in the system, 2 consecutive failures in the system, and between those major time between them, consecutively system should not be down twice a month or more than 2 times a month. This can be another measure for it. So you will observe that the major part of it, we have seen that you need to have some measure to it. And for availability, you can have your different measures. Now this failure, whom does this availability impact? This impacts on the system user. Because if the server goes down, the system user will be able to see it. But there are some other quality attributes which end user may not see directly, but those are defined for the purpose. Now a sample scenario for this is one of the scenarios is there is some virus attack on the system or the specific server. The protection mechanism detects it. The protection antivirus running on the server detects that there has been a malicious attack on the server, or hackers have started attacking it. What system response can be that server is brought down for the diagnosis, that something has happened, the worm has entered into the system and it's creating a problem for us. So server is brought down for the diagnosis. The standby server takes a load. It's a response. It's a response which has been given for the stimulus. Now, what can be the measure of it? Time to switch from server to server. Now, there can be a momentarily disconnect from switching from one server to another, like the DG set example or generator. Even some buildings, I know they have implemented a system that if the electricity fails, simultaneously 2 generators start in exactly same time. And within moments, it is observed the one DG set, which is faster one, starts taking up the loads, the second one goes down. And there can be multiple strategies in these servers as well. We will try to understand in this session the understanding and actually the role where the quality attributes take part in our overall good functioning of the system. So next is modifiability. Modifiability means how easy your system is going to be modified if required. Like our example of, say, the building which will be given on the rent for banks, or it might be for offices or for IT or for anything. If your wall structure is very soft and very quickly to be changed, your system is good modifiable. Now this is involving about a cost of change. Otherwise, the next the person comes who is going to hire the place, and he starts first of all changing the tiles, then changes the walls, then changes almost everything except the column structure, and the cost is too much. But if you know a priori that the system needs to be more modifiable, you might have compromised somewhere else. You might have compromised some other quality attribute by giving more importance to this. That is possible. Now, how do we understand the modifiability? That how easy it is to change the artifact. Our code, artifact means it might be code, it might be test case, it might be design document or anything. Is it very easy to change it? Now, how to achieve this? How to achieve the performance which has been set by the customer for this modifiability? How to achieve it is object-oriented approach. You know that if you make a class model, make a good use of the polymorphism, then you are likely to have the good and a very good modifiable, say, the entities. Now already it's 10 o'clock. We can extend, right? 10 more minutes. I think maybe 10 more minutes we can extend this session, and we will go through the rest of the list. So what can be the measure of this? Maybe number of components which you need to change for making a change. And this is about a modifiability. The performance talks about, this is a very important thing which as an architect you might face. A performance, every person says my system should be very fast. Now, fast means how much fast? It's talking about a timing. It's talking about interrupts, that when an interrupt is generated, the response should come in this much time. Whenever a request comes, the end user must get response in this much time. We are talking about it. When 10 simultaneous users are going to give requests, people expect that all 10 must be getting a good response of it. Of course, person cannot say it needs to be the fastest one, and it should provide input to the thousands of people. It's not possible, because even for McDonald's, say the outlet, we can't say that thousands of people will serve. Okay, up to 25 people, you are going to get guaranteed you will get your order within so much time. But if the users becomes 1,000 or 2,000, you can't give any guarantee. So we need to capture this into numbers. Now, these events can be having a different arrival patterns. Those can be periodic, that sometimes the machine keeps on sending the data every 100 milliseconds. It's very expected periodic nature, but it can be sometimes stochastic, that suddenly if the share prices start increasing, people might start selling very suddenly, and the request of sale might come very fast, or rather in a large volume, and people need to be fulfilled with their appropriate responses. Now, at very high demand, at same time, what is the response time can be a measure for it. Security is, of course, very important aspect of any software, that this fulfills the contradictory requirements, two contradictory requirements. The legitimate users should be allowed to enter into the system. They should not be harassed. And unauthorized users need to be stopped. It's like the people who are entering into the airports. People shouldn't be harassed for something if you have got a very legitimate documents, but for the unauthorized, you should be able to stop them. These are two contradictory things. Now, this term non-repudiation means both the parties, or whenever the exchange is happening between the client and a server, both the parties should get assurance that yes, my request has been taken care of and response has reached to the client, kind of a thing. Confidentiality again is a part of security, that no third person is listening to your conversations. Integrity is important thing, because you can't send half the data. You can't give a guarantee that yes, half the data is going perfectly, but it is not guaranteed that 100% data is going or not. Such a system is of no use. Now, parties who are involved in it, in the communication or in the request response kind of a scenario, the parties must get the assurance that the other party has listened to it, and correctly and with integrity. The availability for the legitimate users and non-availability for the unauthorized usage. Okay. Now, auditing means sometimes who has logged in and what time person has logged in is always getting recorded for reconstruction purpose if required in future. For example, the credit card usage. There are algorithms which are running in the background which might identify the fraud detection algorithms. Or in the the stockbroker or the share broker or the investment banks. You simply cannot fire the SQL query on the database and find out this CEO which shares the person is buying, because you can be caught under the clause of insider trading. And in such a system, security is such a high one that if someone fires unauthorized SQL query on someone else's account, the query gets recorded. Many times it might be rejected, because there is no reason for you to fire such kind of SQL query. So in such a case, the system should be able to record SQL query, who fired it, from which IP, and under what circumstances. Testability, maybe you may not come under very frequently with this kind of the attribute, but system should be easily testable. Means it's like a car, right? Car has got multiple checkpoints that you check the engine oil. If you have opened the bonnet of it, you will have some strip kind of a gauge, and the opening, you put that stick inside and see what is the oil level. You may be able to see on the meter that what RPM the wheels are running. If you connect it, the maintenance person can see it. There are exactly checkpoints. The person will connect a connector to the car computer and will say the diagnosis. So system should be testable. This is the measure can be a probability of failing in next test run. first time it's very difficult to understand this. It should have a very high probability of failing in next test run. What does that mean? That if you apply tests, the test which will detect the failure, the system must fail into that because it's a test run. If system doesn't fail into that test run and system fails in the production environment, it's a loss to you, of course, to the customer also. How this can be achieved? That the internal states and the inputs need to be controllable. That if you tune something, like for the old M80 kind of the scooters, there was the tuning screw available for the idling. Nowadays it is inside the cover, but you can adjust that screw very easily by a screwdriver, and maybe you can control the firing of the two-wheeler for the idling of the engine. Now, by observing the outputs and the auditing things at in between states, so internal state must be available for testability. The important one, and which is little bit has become the very separate domain by itself, or the capability or skill by itself, is a usability. Lot has been talked about it, because the end user who is going to use your system, if end user cannot use your system will be really a wastage. This is a separate branch by itself, and there are, I think, the separate courses for it. But these people are the expert teams. They learn about, is it easy for learning to the features of the system for the user? Is it are people able to use them efficiently? That if at all you have purchased the treadmill and someone is not able to use the treadmill, and afterwards people are just putting for the drying the clothes, its main purpose is not served for it. The minimizing impact of the errors, because if too frequently errors are coming and if the impact is too big, then such a usability is not good. The error pattern must allow the user to correct the things, and adapting to the system user needs. So usability has become really the important aspect of it, which talks about the human-machine interactions. These are some of the quality attributes which we saw concerns about those, the role of those into architecture, and in general, how those can be addressed for having a good system in place. Now I think, yeah, let me still share the screen. If at all there are questions, we may require this. So I think now I will open it for the audience. I know it was overshooting of about 10 minutes, but subject is too big. So let me open it for the question answer session. Any questions or comments? Yeah, feel free. It's not going to be.
Sir, I'm Shivani. I had a question. So, are there any metrics or any system for measuring which non-functional requirements we have met, or anything like functional requirements have, whether we have fulfilled them or not, but anything for non-functional?
Yeah, so Shivani, rightly you mentioned that functional requirements are very easy to give a guarantee or to give evidence that yes, we have run the test cases and the test cases are passing. Similarly, I think one aspect which we did not talk about here due to the time, that is called as the non-functional testing, non-functional requirements testing. There are non-functional requirement testing. Automation is also available, like I think the load runner, and there are some softwares. As far as the number part of it, or quantitative measures or the metrics, and you have what really a very the scientific word metrics, that I like that. As engineers, we should talk in the scientific terms. The metrics, totally there will be industry standard guidelines, but they are really not going to be bound by the customer because systems are in the varying environments. The system which I am going to develop only for the educational purpose can afford to be down for more number of times. But the system which I give the example like the financial share market, and there are no ready-made metrics available. At least, I do not know, maybe I shouldn't claim that there are no. That will be too big commitment or the claim. At least I am not aware of any standards which are available. And maybe you can search, if available, you can share, and not a problem. But there cannot be one requirement which fits for all. It will be always the trade-off between multiple things. But you are right, for object-oriented metrics, there are values or there are guidelines. For example, people say that 25 lines per method, or the fan out, the collaboration between two classes with these many classes relationships and all those. But at least for architecture, maybe I will also search, but I do not think there will be one answer which fits for all the requirements.
Yes, thank you, sir.
Yeah, a good question. I liked it. Yes, then if there are no more questions, can we conclude the session? Okay, then I will hand over the control to the madam. Where do I mute it? I think I need to stop presenting first. Yeah.
Okay. Thank you for the session. It was really a dive deep into the role of quality attributes in software architecture. So I say that the session is over, and then if there are no more questions, then you may leave the meeting. At the same time, I request Tanaya to stop the recording of the meeting.
Okay, so just a moment. Thank you very much, and I'll leave the session now. Okay, thanks and bye.